Dear doctor, my name is ZHAOXUAN. I will start my presentation 1 for assignment 1. And today's presentation has 2 parts. The first one is for case study 1 and the second one is for exercise 1. And for case study 1, this assignment downloads the quarterly date and real personal consumption expenditures and the real disposable personal income for United States. And this is the plot of consumption against the income. And the red line is income, and the blue line is consumption. And we can see that the two variables have the similar trait because they are down uploads, and we can get that there is a clear positive relationship. So we can guess that maybe there is a co-integrate relationship between the two variables. So the study conducts the ADF test to determine the order of integration of variables, and the results of the unit root test using views are shown in the tables. And we can see that consumption here is non-stationary, and the income, the level income, is non-stationary. However, when we take first order of difference for consumptions and the income, and we can see that the zeros become stationary. So we can get that both consumptions and income are non-stationary zeros, which become stationary after the first order difference. In other words, both consumption and income zeros are stationary in the same degree. I1 here I print it. Okay, so we can get the conclusion that the order of integration of variables is I1. Okay, so here is the integration order. Okay, after as there is a co-integration relationship between the consumption and the income, so the study then processed with Johansson co-integration test. And we know that when applying the Johansson co-integration test, the first step we need to do is to create a VAR model, okay? And then use the VAR leg order selection criteria to determine that the optimal leg order. And as shown in the figure, you can see that when the leg is 6, the more criteria choose the leg order. Okay, so because you can see that's the star. Okay, so we can get the conclusion that the leg legends criteria suggest an optimal leg of 6 for the VAR model. Okay, so for this VAR model, the leg order is 6, and after determining the leg order, we need to construct a VAR model again and perform the Johansson co-integration test. As shown in the figure, the trace statistics and the max engine are smaller. Here, this figure and this figure are smaller than the critical values. So it cannot reject the non-hypothesis of at most 1. Okay, so therefore both the trace test and the maximum engine value test show that there are one co-integrating equation at the level 5% level. Okay, here trans test indicates and the max engine value test only one co-integrating equation at the 5% level. Okay. Okay, and then after as one co-integration relationship is found, so the study estimates the long-run equation use the FMOLS. And here is the result of the FMOLS. And we can find that the consumption and the income, the relationship between consumption and the income. This figure is the coefficient of constant, and this figure is the coefficient of income. And we can see that there is a positive long-run relationship between consumptions and the income. Okay, and here we can also get the R square. R square is the 0.99. So we can see that there is a strong positive relationship between consumption and income. Okay, and then study creates the ECM model to model the long-run, short-run dynamics and long-run equilibrium relationship among consumption and income. And we can get that here is a constant, here is error term, and here is first difference, like the first like the difference of consumption, and this one is like the difference of income. And we can see that the results of the relationship. We can see that here is a constant, here is a error term, and here is a coefficient for like the difference of consumption, and here is like the coefficient for like the difference of income. And we can get the first conclusion is that the error correction coefficient is negative here. Here, this figure is negative. So it means that consumption adjusts by 10.04% per quarter to deviations from the long-run equilibrium. Okay. And we also can get that the coefficient value of the like the difference of consumption is 0.208, which is significant. Here we can get that the probability is 0.0052, which is less than the 0.01. So which means that the current fluctuation of consumptions brings about a positive short-term fluctuation equilibrium adjustment. And the coefficient value of the lag difference of income is 0.437, which is also significant because here the probability is 0.000, which is less than the 0.05. So we can get that the differences of constant will bring about a positive short-term volatility equilibrium adjustment because the two coefficient for two variables, both the positive, both the so we can get that the relationship between this variable and this variable with the and consumption is positive. Okay. So this is this is a presentation for case study 1, and then we will continue the exercise 1. And for exercise 1, this study downloads daily exchange rate for the euro and the British pound against the US dollar. And we can also see the plot of Euro USD and the GBP USD. And we also can see that the two variables have similar trait. Okay, down, up, down, up, down, up. Okay, so the two variables have similar trait. So and so we can guess that there is a co-integration relationship between the two variables. Okay, and similarly, we will construct the ADF test. Okay, and to determine the order of integration of variables and the results of the unit root test reviews are shown in the summary table, and we also can get that the level variables are non-stationary. You can see that here, non-stationary, and when we take the first order of the two variables, and we can see that the variables become stationary. Okay, so we can get the conclusion that Euro USD and GBP USD are both non-stationary, which become stationary after the first order difference. In other words, both Euro USD and GBP USD series are stationary in the same degree, I1. Okay, so the order of the integration of variables is I1. So here is I1. Okay. The study then deploys the Engel-Granger two-step co-integration test to investigate the relationship between Euro USD and the GBP USD, and to estimate the long-run equilibrium relationship by running an OLS regression of Euro USD and GBP USD. And we can see here. So we can get that for the long-run relationship, it is positive. Okay, because here coefficient is positive. Okay, and then we will save the residuals. Okay, and name the residual with RES, and please remember this because it will be included in the ECM model. Okay, and then we conduct the ADF test for the RES for the error terms. Okay, and the ADF test shows that the residual series is stationary, so there is co-integration relationship between Euro USD and the GBP USD. Okay, and then estimate an error correction model using the save the residual as the error correction term, just the RES. Okay, and the ECM model results is shown as this figure, and we can conclude that the error correction term, the error correction coefficient is negative here. The coefficient for RES is minus 0.003. So the error correction coefficient is negative, and the adjustment coefficient indicates that Euro USD adjusts by 0.35% per day to deviations from the long-run equilibrium. Okay, and we also can get that here the coefficient for the of the difference of GBP USD is 0.4867, which is significant. Okay, here the probability is 0. So we can get that the relationship between GBP USD and Euro USD is significant. Okay, so it means that the difference of GBP USD will bring about a short-term volatility equilibrium adjustment. Okay, so when we predict the future exchange rate of the Euro USD, we can use the exchange rate of GBP USD as the baseline. This is practical implications. Okay, so this is my presentation, and It will end. Thank you.